All right, you guys. So last section for chapter 11, and we're nearing the end of our course as well. So hang in there. We are almost done. Basically, in this chapter, we're going to solve inequalities. So remember, what inequalities represent is a situation where something is greater than or equal to, greater than, less than, or less than or equal to another situation. For us, since we're studying quadratics, we're going to be studying quadratics of this sort, like x squared plus x minus 6 is greater than 0. So our inequalities for this section will basically involve quadratics. All right, so there's kind of a reminder of what that is. And fortunately for us, what's nice about a quadratic is that the graph of quadratics, again, can help us out. As we saw in 11.8, since we're talking about a function that's basically opening downward or opening upward, right? We actually can take advantage of that situation to help us solve quadratics. And then that combined with the x-intercepts that we find, if I can spell it there, right? So the graph and the x-intercepts will give us a good indication of how these things are solved. So the game plan will basically come as we kind of do this problem here that I invented, right? Because in terms of x squared plus x minus 6, I see that it's a quadratic and the lead coefficient is 1. So I know for a fact it's a quadratic that's opening up, right? So if I had my x and y axes, I know this guy is opening up somewhere like this. If I now find the intercepts, right? So we do that. Again, finding intercepts, we're actually going to set our function equal to 0. So I'm not even worried about the inequality. In this case, we can factor it, right? So x plus 3, x minus 2 equals 0. And then this means that x plus 3 is 0 or x minus 2 is 0. So we basically have two x-intercepts. So I'll come back to my graph, and I know that on this graph, we're crossing the x-axis at 2, 0, and we're crossing the x-axis at 3, 0. And then if you wanted to find the vertex, you could, but it's not necessary. I just know that this function is doing something like this. So that's actually good enough for everything we need to do. Back to the inequality, I want to know when this function is greater than 0, which basically means that y is greater than 0, which basically means we are above the x-axis. So you can see for the little problem that I made here, right, starting at this guy here and for x values here, the graph is above the x-axis. And starting at this x-intercept here, and for these x values there, we are above the x-axis. So the solution in interval notation would be from negative infinity up to negative 3, right? That would capture those x values where the function's above the x-axis or greater than 0, union 2 to infinity. Again, these would represent the x values where the function's above the x-axis or were greater than 0. So there's going to be our strategy. You notice I'm using the fact that we have a parabolic graph combined with the fact that we have and can find intercepts. Those two things alone give us a quick sketch. And then from that sketch, I can just basically look and when am I above or below or touching the x-axis, and I pretty much have my answer. So there's your game plan, right? So the game plan basically is to, I guess step 1, if you wanted to, is to try to take note whether we have a parabola opening up or down. So again, this will be a less than 0 or a greater than 0, right? Remember, a is the leading coefficient. So that's step 1. Step 2, you're going to find the x-intercepts, right? So essentially, you're going to find when is the function equal to 0. And then you're going to step 3, excuse me. We're going to use this above info to sketch a graph. All right, and then that leads us basically to step 4, where we basically highlight. How about I say that? highlight the intervals along x-axis that satisfy the condition. Right? And then I guess there's maybe a fifth step. You guys know me, I want your answers in interval notation. All right, that is the best way to put our answers. So you kind of see I did that with this make-believe problem. So I started with an inequality. I made note of what kind of graph I'm going to have, right? I found my x-intercepts, gave me a sketch, and then I was able to highlight the regions along the x-axis that satisfy the given condition. All right, so that's our strategy. You're going to watch me do it several times in some videos coming soon. Talk to you guys later.